Thank you, thank you. So in this workshop, I will talk about how to build safe smart contracts, and I will try to make it as interactive as possible. So if you have any questions or anything that is not clear, feel free to stop me at any time, and I will try to answer. So first of all, I'm Luis, the protocol architect at Trello, and I'm also a senior auditor at Paladin, which is an audit company. And yeah, let's go. So why smart contract security is important? So first of all, you probably have seen a lot of hacks happening recently and not really recently. Just if you go to the React leaderboard, there is probably 10 billions that were stolen from multiple hacks and multiple things. And we will cover the most common vulnerabilities and also the fixes of those vulnerabilities and what are the best practices and everything that you can do to try to mitigate the likelihood of being exploited in your smart contracts. So let's start with the common vulnerabilities, and there will be a lot of codes that I will try to explain, but they are kept minimal so that everyone should be able to understand. And let's try so that you can find the issue and how to fix it. So let's start with the first contract. There is a tips just with the contract name on top. It's an invalidated user input, so you need to find where is the invalidated input and what's the damage. So the first function is a deposit function where you can just increase the balance of yourself by transferring a token, and there is a withdraw function to be able to withdraw your token. Does anyone see a flaw in this contract, or no one yet? So the idea is that you need to look at the inputs. So this is the token and the amount, and think when you see this contract, what could go wrong if someone, a malicious user, was not using, for example, the front end, and the parameters were not verified. So, let's assume it's only Solidity 0.8 plus, so there is the underflow and overflow is already checked. Yes? Sorry? Yes, but it's only your balance. It's still checked to be the amount. But it's something close to that. I think someone had an idea? Yep. The idea is that the token is not validated. So for example, here you can send a worthless token, something that you just created yourself, and it will increase your balance by 10, for example. And then you try to withdraw USDC. And it doesn't check that you deposited USDC or anything, and you can just steal everything. So that's the idea. So the fix is just to, instead of having the token as an input, to have it as a parameter. And then when you deposit, it uses the trusted token and not the other one. So that's the first thing. You should never trust user inputs, and you should always validate them. It could have been made by whitelisting multiple tokens if the idea was to have multiple tokens, but you would have to have another parameter so that the balance take the token as well. Let's see the unsafe downcasting. It's basically the same contracts. Now the token is validated, everything is fine. The only difference is that now someone sends the amount, it verifies everything, but it casts the amount as uint 1 to 8. Let's assume this function was taking that. Can anyone see an issue with these contracts now? Exactly. If, for example, the user inputs 2 to the power of 1 to 8, which is 1 with 1 to 8 0 after that, the uint 1 to 8 casting will downcast it to 0. So in fact, it will increase, sorry, in deposit, it will increase the balance by 2 to the power of 1 to 8, but it will transfer literally 0. And then you can withdraw just lower than the max amount, and it will just run fine and will send the amount. So when you cast a value to like downcasting, so something bigger like uint 256 to uint 128, you need to verify that the amount is lower than the maximum that can be in the uint, or use a safe cast libraries. For example, the OpenZeppelin's one are really great, but I tried to make it as minimum as possible, so it just verifies the amount directly here. But yeah, so that's the second idea. It's to never downcast things without first verify that it doesn't break anything. Then let's talk about the big one, the reentrancy function. So this is still the same idea, but instead of having a token, we send AVAX directly. And so it goes as follows, but in the withdraw function, you can only withdraw your entire balance. Can anyone see an issue using reentrancy and this contract to steal everything, basically? Yes? Yep. Exactly. When you call withdraw, it will take your balance, then transfer AVAX. If you go to transfer AVAX, it does an external call to send the amount. However, this call can do anything. So the idea is to use a contract that when you will send the AVAX, will withdraw again, and as the balance was not updated yet, it will withdraw again the same amount. And you can do this over and over and over to just empty the entire contract. So how to fix this? There is two solutions. One is to follow the check effect interaction rules, which is very important. It's that first you need to check things. So this is, you take the balance, then you do the effects. So the effects is updating the balance, and then you do the interaction. Interaction is when user can do stuff with an external call, and the external call is just there. By doing so, we just flipped those two lines. Now, if we try the same exploit again, the amount will be 10, for example. It will be set to 0. It sends 10. Now you try to re-enter again, but amount now is 0, and so you can't steal everything. Whereas before, just by switching those two lines. And this is very important. The check interaction rules, check effect interaction rules, sorry, is very, very important. But sometimes you can't do the check effect interaction if, for example, you need the output of something, like calling a router or something like that, and then you should use a reentrancy guard. So this is using the OpenZeppelin's one, and it's simple. It doesn't even need to swap those two tokens. It adds a non-reentrant modifier. What does this do? Basically, it will check that when you do any when you are in the withdraw function, sorry, you can't re-enter again in the withdraw function. So it means that if you try withdraw in the call withdraw again, it will just revert. So it's safe, but most of the time you should try to follow the check effect interaction rules. But we will talk about that a bit more later. Another issue is the stolen private key. So this is a contract, basically a bridge, very minimal. Any user can call bridge2, which will burn their token, send a message, and in the other chain, the message will be caught by an admin that will call mint, and that will basically just mint the tokens, and etc. Now, let's assume that the admin had its key stolen. What can go wrong in this contract? Anyone? Yes? Yeah, exactly. As the admin can call mint without any check, it doesn't have to check that the bridge2 function was used. If the admin is ever compromised, so for example, the key was lost or it was in an unsafe computer that was hacked, then the mint can be called over and over and over. How can you mitigate this? You can't really. So you need to make sure that the admin's keys are not stolen, and for that, for example, it's better to always roll your keys. So every month or something like that, you change the admin key so that even if it was hacked or in a computer that is unsafe, the key is not used anymore, so it's not a big deal. And when it's possible, it's always better to use multi-signatures contracts instead of just one admin. The difference is that the multi-signature will require multiple admins to sign a message before it's valid. And so instead of having just one key that can call this contract, you would need to steal 2, 3, or multiples, which reduce the likelihood of this happening. But there is not easy fix, so let's just go to the next one. This one is called unsafe loop. So it's basically a contract where you stake some tokens, and every day you can call distributes to gain some tokens. It doesn't really matter what the contract does, but the idea is that the amounts that you burnt is added to user and amounts, and then it's minted again every day. What can go wrong in this contract? If we don't take into account the overflow issue, because at one point the distribute will revert because of overflow. Does anyone have an idea using? Exactly. The idea is that anyone can call stake, and even multiple times. So the idea is to make it so that the user array is, and amounts as well, is so big that you can't call it in a single call because it will take too much gas. In Avalanche, gas is 50 millions, and relatively, a min function will cost 30K gas. So if you do 50 million divided by 30K, it does something. I don't have the result, but whatever. And this is the maximum amount that you will be able to iterate before this function will revert, and you will never be able to call it again. So this idea of iterating on something is always bad in Solidity, because it costs first a lot of gas, and most of the time it can revert because of gas attacks, to just inflate the array so high that it will just revert. So if your contract ever have a for loop on an array that can increase indefinitely, it's a bad idea, and you should try to find another idea. Most of the time, when someone wants to do a contract like this, it's for a rewarder or something like that. And instead of iterating on the user, you should use a master chef-like contract that will distribute the reward accordingly to the stakes, but without actually iterating on everyone. Let's go to the next one. It's a simple swap function when you send some token in, and you call an exchange to swap some token, and that's it. It's called front run, so the issue will have something to deal with being front run. Does anyone have an idea on how you could front run someone to steal some tokens? No? Sorry? Yes, exactly. The idea is that the amount out is not checked. So when someone will see in the mempool that you are sending some tokens to the exchange, what he will do, he will reduce the price very, very, very low, so that the amount out is almost zero, and then he will swap back again. And it's called the sandwich attack, exactly. That way you can just steal some tokens. And the way to reduce this impact is to add just the parameters, which is amount out min, and then make sure that the amount out of the exchange is at least equal or bigger than the minimum. That way, the impact of the sandwich will never be higher than the minimum, which is a way to mitigate front-run attacks. But you could use some flashbots, RPC, and other stuff like that, which would hide your transaction in the mempool so that no one will be able to front-run it. But it's still better to have some slippage. So we saw the most common smart contracts attacks. Let's talk again about the check effect interaction rule, because it's probably one of the most important one. The idea is to always make sure that you update every state of your contract before calling an external contract. That way, if you always update like the balance, most of the time it's a balance. If you update the balance before allowing any change by the user, even if he re-enters or even if he calls in a bad way, nothing should happen. And when it's not possible to follow the check effect interaction, you should always have a re-entrancy guard. For example, if you transfer tokens, sometimes there is a transfer tax, and you will not receive the same amount that was transferred. And in this case, you need to use a balance before and balance after to calculate the amount that the contract received. But this pattern is actually a reentrancy exploitable. So you can inflate your amounts that was sent by reentering again. And then it's very important to add a reentrancy check on those contracts. So following the best practices of coding is very important. You can see them in the Solidity docs directly, or just follow the OpenZeppelin ones. Both are very good. The idea is to, for example, group the functions with the like external public are together, admin function are together, and private and internals are together as well. That way, you reduce the likelihood of missing the fact that a private function was made public, for example, and very bad thing could happen in this case. So just by sorting them accordingly and by reading your contract, you should be able to see it. And if not, tests are very, very important, unit testing, to make sure that your contract will behave the way it's supposed to do. For that, you can use Hardhat if you love to write JavaScript tests, or Foundry if you want to write them in Solidity directly. I recommend Foundry because it's, to me, easier to use, and it integrates some other toolings like fuzzing directly, and it's really, really easy to use. If you want to do more fuzzing, you should go to Echidna, which is a fuzzing software that does fuzzing better than Foundry, but it's a bit harder to use. And you can do even invariant testing to verify that the invariants are true. For example, in the lending market, you should always check that the user life check is higher than 1, so that it's not liquidated directly when he does its position. And this can be verified with invariant testing, and it's very, very strong. Then you should always try to do some audits, whereas it's private audits, big company audits, or even Code Arena, Sherlock audits. The idea is that other people will be able to review your code is very important, especially someone that is better at security stuff than you, so that he can think outside the box how to exploit your contract. And then the last layer of security is the bug bounty system, where basically someone finds an attack in your contract, but instead of hacking it, it will display it to you. It will tell you what's the issue and how to fix it, and in exchange you will give him a bounty. It's most of the time 1% of the stake involved. So if you have like 10 million in your contract, it can be 10% of it, 5%. Something that you can decide with the white hat. Sorry. Thank you for your attention. Do you have any question on this workshop, or like any questions at all on smart contracts or smart contract security? Feel free to ask them here or when I'm in the back of the room at any time. No? All good? Okay. Thank you.